One of the things to consider when you have expressions with leading coefficients other than 1 is look to factor anything else that's simpler first. So since there's multiple ways that I could factor this, I'm going to wait and I'm going to factor the denominator first. So when I factor my denominator, I have s plus 1, s minus 1. The difference of squares factors into the sum and difference of terms. And the reason that this can be helpful is that more than likely, one of my factors for this numerator is going to be one of these two things. So I'm going to put an s and a 1 here. It could be plus, could be minus. And I'm going to use reverse FOIL if I look at my trilinear. If I wanted to multiply 1s times something to get 9s squared, my only option would be 9s. From 1 to get 5, it needs to be a 5. And so these are either both positives or both negatives. And so when I take my outer and inner sum is a negative, so I know that these are negatives. So I'm going to test this first. It might not work, but using trial and error is generally pretty good if you can pick some of the options from the other factors. So here when I take my outer and inners, I get minus 9x minus 5x does give me minus 14, or 9s minus 5s does give me negative 14s. And so these are my correct factors, which I can then cancel my common factor, and I get my solution of 9s minus 5 divided by s plus 1. Okay, so there's my simplified form. I did cancel a factor from my denominator, so I have to account for that domain restriction. S cannot be a 1. Is that restriction demonstrated or apparent in the simplified form? It is not. So I include 1 here, and that is my total answer. Again, this doesn't mean that s can only not be 1. S can also not be negative 1. But we see that in the simplified form. It represents a vertical asymptote for the graph of this function. But the 1 in our additional restrictions represents a hole in that graph.